Hello there, and welcome to the Sleepy Science Channel. I'm so glad you're here. Maybe it's been a long day, or maybe you're the kind of person who likes to fall asleep while thinking about lost worlds and forgotten creatures instead of counting sheep. Either way, tonight's journey is for you. You don't need to do anything now but rest. Let your breath slow, your thoughts soften, and your body grow heavy, as if it's been part of the earth for a very, very long time. Because tonight, we're going to drift gently through the fossil record, not in a straight line, but along a path made of vanished bones and ancient DNA. A story told not in words, but in armor plates, spiral teeth, and ancient wings stretched across vanished skies. From giant sloths and demon ducks to sea scorpions and flying reptiles, extinction has taken many forms, and every one has something to teach us. We'll go slowly, gently, just one strange fact at a time. And just before we begin, if these quiet explorations help you unwind or give you a peaceful way to end your day, consider gently tapping the like button and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. Giant insects once flew with wings wider than a seagull's. Around 300 million years ago, during the Carboniferous period, the skies were filled with insects unlike anything alive today. One of the most striking was Meganeura, a dragonfly-like predator with a wingspan stretching more than 2.5 feet across. That's larger than many modern birds. Insects don't breathe with lungs, but absorb oxygen through tiny tubes in their bodies. And during this period, atmospheric oxygen was significantly higher than it is today. That allowed their bodies to grow much larger than modern insects can manage. As oxygen levels later dropped, these aerial giants vanished, leaving behind only fossilized impressions of their wings and bodies. Australia was once home to birds taller than a grown man. In prehistoric Australia, a family of birds known as dromornithids included some of the tallest avians to ever exist. One species, Dromornis statoni, stood close to 10 feet tall and may have weighed over 1,000 pounds. Despite being related to ducks and geese, these birds couldn't fly. Instead, they lumbered through forests and grasslands on powerful legs. Their massive beaks may have been used to crush tough vegetation, though some scientists believe they were capable of eating meat as well. These towering birds lived alongside marsupial predators and may have used their size for defense. They disappeared around 30,000 years ago, likely after the arrival of early humans. Some prehistoric armadillos were the size of small cars. During the Ice Age, South America was home to enormous armored mammals known as glyptodonts. These creatures were relatives of modern armadillos, but their bodies were built like tanks. One of the largest species had a shell more than 6 feet long and a tail covered in bony rings that may have been used like a club. Their armor was composed of fused plates, offering protection from predators like saber-toothed cats. Despite their defenses, glyptodonts were peaceful grazers, feeding on grasses and low-lying plants. Fossils suggest that early humans may have hunted them for meat and used their empty shells as shelters or storage spaces. The skies of the past were ruled by reptiles as tall as giraffes. One of the most impressive flying animals in history was Quetzalcoatlus, a pterosaur with a wingspan of over 35 feet. Unlike birds, pterosaurs had membranous wings supported by elongated fingers, and Quetzalcoatlus used a unique four-limbed launch to take off. On land, it likely stalked prey like a stork, using its long beak to snatch small animals or fish. Despite its size, its bones were hollow and reinforced to keep its body light enough for flight. It lived near the end of the Cretaceous period and vanished during the same extinction event that wiped out the dinosaurs. Its fossil remains have helped reshape our understanding of prehistoric flight. The thylacine looked like a dog but carried its young in a pouch. Also known as the Tasmanian tiger, the thylacine was a marsupial predator that once lived throughout Australia and Tasmania. It had a striped lower back, a stiff, straight tail, and a jaw that could open nearly 100 degrees wide. Though it resembled a wild dog or wolf, it was more closely related to kangaroos and wombats. Thylacines were solitary and mostly nocturnal, feeding on small mammals and birds. They were declared extinct in the 1930 after decades of habitat loss, hunting, and competition with introduced animals. The last known individual died in captivity in 1936, though occasional unconfirmed sightings have persisted for decades. One ancient shark had teeth that spiraled like a circular saw. The prehistoric fish known as Helicoprion puzzled paleontologists for over a century. Its fossil record consists almost entirely of a tightly wound spiral of teeth, a structure unlike anything found in modern animals. Early reconstructions placed this buzzsaw in various parts of the skull, but the most supported theory today places it in the lower jaw. The spiral functioned like a conveyor belt, with new teeth forming at the back and older ones rotating forward. It likely fed on soft-bodied prey such as squid, slicing them with rapid bites. Helicoprion lived more than 200 million years ago, in oceans that held many forms of bizarre life. Saber-toothed cats ambushed their prey with enormous, curved fangs. The most iconic of these predators was Smilodon fatalis, often called the saber-toothed cat. It lived in the Americas during the Ice Age and was built for power rather than speed. Its forelimbs were thick and muscular, perfect for wrestling large prey to the ground. The famous canines could grow over 7 inches long but were relatively fragile, better suited for slicing soft tissue than crushing bone. Unlike modern big cats, Smilodon likely hunted by ambush, using cover to get close before attacking. Fossils found in tar pits suggest they hunted animals like bison and camels, and may have lived in small cooperative groups. Some mammals lived in trees during the age of the dinosaurs. One such creature was Tilidus, a member of a now extinct group called multituberculates. These small mammals had rodent-like teeth and grasping hands adapted for climbing. They lived in forests during the late Cretaceous period, at a time when dinosaurs still dominated the land. Fossil evidence shows they were agile, nocturnal foragers, feeding on seeds, fruit, and insects. Their long tails likely helped with balance as they moved through the branches. Though multituberculates thrived for over 100 million years, they eventually disappeared after the rise of modern placental mammals, which may have outcompeted them for ecological niches in the post-EB dinosaur world. One dinosaur had arms longer than most humans at all. Dinoceras was a massive duck-billed dinosaur with arms that stretched over 8 feet long. For decades, only its gigantic forelimbs had been discovered, leading to wild speculation about what kind of creature it was. When more complete fossils were finally uncovered in Mongolia, scientists found an animal unlike any other, a humpbacked, long-armed omnivore with hoof-like claws. It likely used its powerful limbs to dig for plants or root through muddy riverbanks. Despite its intimidating size, Dinoceras had a broad, toothless beak and may have lived a peaceful life grazing near lakes and streams during the late Cretaceous. The largest shark in history may have bitten whales in half. Megalodon was a prehistoric shark that likely reached lengths of over 60 feet, more than 3 times the size of a great white. Its teeth were serrated and triangular, some over 7 inches long, perfect for tearing through thick flesh. Fossils show it lived between 20 and 3 million years ago, and likely preyed on early whales, sea cows, and large fish. Its jaws could open wide enough to swallow a person whole, and its bite force is estimated to be one of the strongest of any known predator. Though once feared to still exist, Megalodon is long gone, leaving behind only teeth and vertebral fragments. Some prehistoric frogs were big enough to eat baby dinosaurs. Nicknamed the devil frog, Beelzebufo lived in what is now Madagascar, around 70 million years ago. It grew over 16 inches long and weighed as much as 5 pounds, making it one of the largest frogs ever discovered. With a wide, powerful mouth and bony armor on its head, it likely behaved more like a toad, lying in wait to ambush passing prey. Modern horned frogs from South America use similar tactics, and Beelzebufo may have tackled anything it could fit in its jaws, including hatchling dinosaurs. Its discovery has helped scientists understand ancient frog evolution and how amphibians adapted to changing ecosystems. A feathered creature once swam through Cambrian oceans. Opabinia was a soft-bodied marine animal that lived over 500 million years ago during the Cambrian explosion. It measured only a few inches long but looked like something from a dream or a nightmare. Its most striking features were its 5 eyes and a long, flexible snout ending in a claw-like structure. Scientists believe it used this appendage to probe the seafloor and bring food to its backward-facing mouth. Opabinia had flaps along its sides for swimming and may have moved in a gentle, undulating motion. It belonged to a group of creatures with no living relatives, offering a glimpse into the truly alien forms early life once took. One Ice Age bear was tall enough to look you in the eye. The giant short-faced bear, known as Arctodus simus, was one of the largest terrestrial mammalian carnivores to ever live. Standing upright, it may have reached heights over 11 feet. It roamed across North America during the Pleistocene epoch and had long limbs built for speed rather than brute strength. Unlike today's grizzlies, it likely covered vast distances in search of food, scavenging carcasses, and possibly intimidating other predators into giving up their kills. Its shortened snout gave it a distinctive facial structure, and its sheer size made it a dominant force in Ice Age ecosystems. As the climate changed and large prey disappeared, the short-faced bear vanished as well. Prehistoric pig beasts once roamed with skulls built for crushing. Entelon and its relatives were part of a group often nicknamed hell pigs, though they weren't pigs at all. These hoofed mammals lived in Eurasia and North America during the Eocene and Oligocene epochs and were built like tanks, with long legs, muscular necks, and jaws capable of delivering a powerful bite. Fossil evidence suggests they were omnivores, feeding on plants, carrion, and perhaps even hunting small animals. Their large skulls, some over 3 feet long, were reinforced with bone ridges that gave them a fearsome appearance. Though they went extinct around 20 million years ago, their bones hint at a lineage of mammals far stranger than most people realize. Some ancient jawless animals remain a complete mystery. Paleospondylus, a tiny aquatic creature from the Devonian period, has puzzled scientists for more than a century. It was first discovered in Scotland in the late 1800s and measures just a few centimeters long, yet its anatomy defies easy classification. It appears to have a cartilaginous skeleton, but lacks any clear jaws, fins, or eyes. Some studies suggest it might be a larval form of a known species, while others believe it belongs to an entirely separate branch of early vertebrate life. Its fossils are beautifully preserved but reveal few details about how it lived or what it evolved from, making it one of the strangest unsolved cases in paleontology. Ground sloths once grew larger than modern elephants. While today's tree sloths are small and slow-moving, their extinct relatives were giants of the Ice Age. Species like Eremotherium could reach lengths of 20 feet and weigh over 4 tons. These enormous herbivores lived throughout the Americas and used their massive claws to pull down branches or dig into the ground for roots. Despite their size, they walked on the sides of their feet, and some evidence suggests they could even stand upright to reach higher vegetation. Fossils show that they were widespread and adapted to a variety of environments. Like many megafauna, they vanished at the end of the last ice age, possibly due to climate change and human hunting. The Cambrian seas were full of creatures covered in spines. Among the most unusual was Hallucigenia, a tiny worm-like animal with rows of spines along its back and delicate tentacle-like limbs along its underside. Discovered in Canada's Burgess Shale, Hallucigenia baffled scientists when it was first found. In fact, for years, it was reconstructed upside down. It lived over 500 million years ago and likely crept across the seafloor, using its flexible limbs to move and possibly to filter food particles from the sediment. Its bizarre body plan has no direct modern equivalent, but genetic studies suggest it may be distantly related to velvet worms. Its name reflects the dreamlike strangeness of Earth's earliest animal life. Flightless birds once hunted prey across ancient grasslands. Known collectively as terror birds, members of the family Phorusrhacidae ruled South America for tens of millions of years after the dinosaurs died out. Some species stood nearly 10 feet tall and were fast, agile runners with strong legs and curved beaks built for striking. Unlike modern ostriches or emus, terror birds were active predators, capable of chasing down small mammals and possibly using their beaks to deliver fatal blows. Their closest living relatives are thought to be the tiny, gentle-looking Syriamas of South America. Terror birds eventually disappeared as true mammalian predators like big cats arrived from the north, and competition intensified. The oceans once held fish, armored, like medieval knights. One of the most formidable was Dumpleosteus, a massive predator from the Devonian period. It could grow over 30 feet long and had a bony skull made of thick, interlocking plates. Instead of true teeth, it used sharpened bone plates that formed a natural pair of shears, capable of slicing through the armor of other ancient fish. Its jaw muscles were so strong that it could open and close its mouth in a fraction of a second, creating a powerful vacuum to pull in prey. As an apex predator, Dunkleosteus ruled the seas over 350 million years ago, long before sharks rose to dominance. Giant birds in New Zealand vanished after humans arrived. The moa were flightless herbivorous birds that once roamed the forests and grasslands of New Zealand. Some species reached up to 12 feet in height when fully upright, making them among the tallest birds to ever live. They had no wings at all, not even vestigial ones, and their size evolved in part due to the lack of mammalian predators. Moa were hunted to extinction within a few centuries of human arrival in the region. Archaeological sites show evidence of large-scale hunting, and their eggs, each one weighing up to 7 pounds, were also collected. Their only natural predator, the host's eagle, disappeared shortly afterward due to the loss of its food source. Early people hunted a sea duck all the way to extinction. Chenditzlawi was a large, flightless sea duck native to the California coast. It lived alongside early human populations and showed remarkable adaptations for diving and coastal foraging. Unlike modern ducks, Chendites likely relied on strong legs and a streamlined body to swim through kelp forests and rocky shorelines in search of food. Radiocarbon dating reveals that humans hunted this bird for over 8,000 years, making it one of the longest known examples of sustained human predation leading to extinction. Its story offers insight into how even slow, long-term pressures from human communities can eventually drive a species beyond recovery. Some ancient sharks looked more like eels than predators. Xenacanthus was a freshwater shark that lived for over 200 million years, from the Carboniferous to the Triassic. Unlike today's sharks, Its body was elongated and snake-like, with a dorsal fin that ran the entire length of its back and merged into the tail. It also had a distinctive spine that projected from the back of its head, possibly for defense. Fossilized teeth suggest it fed on fish, amphibians, and soft-bodied invertebrates. Xenacanthus lived in rivers, swamps, and lakes, thriving in environments that were very different from the open oceans where most modern sharks are found. Its eel-like shape gave it a unique niche in prehistoric ecosystems. One extinct sea animal had a trunk and stalked eyes. Erpibinia was a small, soft-bodied creature from the Cambrian period, known for its utterly alien appearance. It had 5 eyes mounted on flexible stalks and a long, tube-like proboscis, ending in a claw. This appendage likely helped it scoop food from the seafloor into its backward-facing mouth. Measuring just a few inches long, Erpibinia swam using side flaps and may have hovered near the bottom, filtering particles or catching tiny prey. Its body plan doesn't match any modern animal group, and it represents one of the many evolutionary experiments that emerged during the Cambrian explosion. Its fossilized remains continue to challenge scientists' understanding of early animal life. Not all saber-toothed creatures were cats, or even placental. Thylacolosmilus lived in South America and looked remarkably like a saber-toothed cat, but it belonged to a completely different group of mammals called metatherians, the same lineage that includes marsupials. It had long, curved upper canines that extended far below its jawline, protected by deep, bony flanges on either side of the face. Its teeth were rooted differently than those of Smilodon, and it likely hunted in a different way, using precise slashing strikes rather than brute strength. Despite their similar appearance, Thylacolosmilus and saber-toothed cats are an example of convergent evolution, where unrelated animals develop the same traits to solve similar problems in their environments. The Cambrian period produced predators like nothing alive today. One of the earliest known apex predators was Anomalocaris, a soft-bodied marine animal that lived over 500 million years ago. It grew up to 3 feet long, enormous by Cambrian standards, and had a pair of grasping appendages near its mouth, which it used to snatch prey. Its circular mouth was lined with tooth-like plates that could crush the hard shells of trilobites, one of its likely food sources. With large, compound eyes and flaps along its sides for propulsion, Anomalocaris was a swift swimmer and a dominant hunter. Its strange anatomy was so unfamiliar that early scientists mistakenly assembled its fossils from multiple species. Some giant carnivores walked on hooves, not paws. Andrewsarchus was an enormous wolf-like mammal that lived during the Eocene epoch, around 45 million years ago. It may have reached 12 feet in length and weighed over 1,000 pounds, with a skull nearly 3 feet long. Though it resembled a predator, its exact diet remains uncertain. Some paleontologists believe it was a scavenger, while others argue it may have hunted actively. Its hooved feet and body structure suggest it was related to early ungulates, the ancestors of sheep, cows, and deer. With only a skull and partial skeleton to work from, the full picture of Andrewsarchus remains one of paleontology's enduring mysteries. One flying reptile had a wingspan wider than a van. Hatzegopteryx was a pterosaur that lived in what is now Romania during the late Cretaceous period. Its wings may have stretched over 30 feet across, but unlike the slender Quetzalcoatlus, Hatzegopteryx had a stockier build and a massive reinforced skull. It lived on a prehistoric island and may have hunted land-dwelling prey, including small dinosaurs. With hollow bones and powerful flight muscles, it was built for short bursts of movement both on land and in the air. Its strong jaws and bite force suggest it could crush bone, making it one of the top predators in its ecosystem. Fossil finds are rare, but each one adds to the story of this extraordinary hunter. Early elephant relatives sometimes had spiral-shaped tusks. Mastodons were distant cousins of modern elephants and lived throughout North and Central America during the Ice Age. Though similar in appearance to mammoths, they had shorter legs, flatter heads, and tusks that often curved dramatically in spirals. These tusks may have been used for defense, digging, or dominance displays during mating rituals. Unlike mammoths, mastodons had cusped teeth adapted for chewing leaves, twigs, and shrubs, suggesting they preferred forested environments. Their bones and teeth have been found across much of North America, often in areas where they were hunted by early humans. They vanished around 10,000 years ago during a wave of megafaunal extinctions. One ancient whale still had visible legs. Basilosaurus was a fully aquatic whale that lived around 40 million years ago, but unlike modern whales, it still had tiny hind limbs with toes. These vestigial legs were no longer used for walking, but may have played a role in mating. Basilosaurus could grow over 60 feet long and had an elongated serpentine body that made it one of the top marine predators of its time. It fed on fish and other marine mammals, using sharp teeth and a powerful bite. Fossils show that its skull and jaw structure had already evolved for underwater hearing, marking a major step in whale evolution from land-dwelling ancestors to oceanic giants. The largest sea cow ever recorded lived in Arctic waters. Stella's sea cow was a massive marine herbivore that once lived along the coasts of the Bering Sea. It could reach lengths of up to 30 feet and weigh over 8 tons, feeding on seagrasses and kelp in shallow, frigid waters. First documented by European explorers in the mid-1700s AD, it was extinct less than 30 years later due to relentless hunting. With no natural fear of humans and a slow reproductive rate, it stood little chance once it was discovered. Unlike modern manatees, Stella's sea cow had thick, bark-like skin and a highly social nature, often found in groups. Its rapid extinction is one of the earliest examples of human-caused marine loss. Some Ice Age mammals looked like camels with trunks. Macrauchenia was a strange-looking herbivore that lived in South America during the Pleistocene epoch. Its body resembled that of a camel, with long legs and a deep chest, but its skull had he-said nostrils, suggesting it may have had a short, flexible trunk like a tapir or elephant. This trunk would have helped it forage for leaves and grasses in diverse environments, from forests to open plains. Despite its appearance, Macrauchenia was not closely related to elephants or camels, but belonged to an extinct group of hoofed mammals unique to South America. It likely disappeared after the arrival of humans and the climate shifts that followed the last ice age. One dinosaur may have been the largest land animal ever. Amphicolius is a contender for the biggest dinosaur, and possibly the largest terrestrial creature of all time. Based on limited fossil evidence, paleontologists estimate it may have reached lengths of up to 100 feet. It belonged to the sauropods, a group of long-necked plant-eating dinosaurs known for their enormous size and gentle nature. Like other sauropods, it likely had a long tail for balance and a massive gut for digesting tough vegetation. Unfortunately, the only known specimen of Amphicolius has been lost, making it difficult to confirm its size. Even so, its legend continues to fuel scientific debate about the upper limits of land-based life. The first vertebrates to walk on land had fish-like bodies. Ichthyostega lived around 375 million years ago and was among the earliest animals to transition from water to land. It had limbs with digits, but its body still resembled that of a lobe-finned fish, complete with a tail fin and gills. Its skull was flat and broad, with eyes on top, suggesting it hunted in shallow, swampy waters. Though it could move on land, it was probably more agile in the water. Ichthyostega marks a key moment in evolutionary history, when vertebrates first began exploring terrestrial environments. Its fossilized skeletons reveal the gradual reshaping of fins into limbs and the adaptation of lungs for breathing air. Some prehistoric elephants had flat jaws shaped like shovels. Platybelodon was an early relative of modern elephants, but its appearance was truly unusual. It had a long, trunk-like upper lip and a lower jaw that ended in a broad, flat extension lined with teeth. Scientists believe it used this shovel-like structure to cut and scoop aquatic vegetation, pulling plants from swampy ground and slicing them against its toothy jaw. It lived during the Miocene epoch and inhabited regions of Asia and Africa. While its tusks were shorter than those of today's elephants, its specialized mouth made it a highly adapted feeder in wetland environments. Its extinction may have followed changes in climate and the drying of its habitats. A tiny worm-like animal may have been our earliest ancestor. Picaia is one of the earliest known chordates, a group of animals that includes all vertebrates. It lived over 500 million years ago during the Cambrian period and was discovered in Canada's Burgess Shale. Though only a few centimeters long, Picaia had a flexible, segmented body and a notochord, the primitive backbone that characterizes the chordate lineage. It swam using gentle undulations and likely fed by filtering particles from the water. Its simple form may have been the starting point for the evolution of fish, amphibians, reptiles, birds, and mammals. In this humble, ribbon-like creature, we may see the first outline of our own biological story. The ocean floor once crawled with armored slug-like creatures. Wiwaxia was a small, soft-bodied animal that lived during the Cambrian explosion, around 500 million years ago. It resembled a slug covered in overlapping scales and spikes, providing a kind of built-in armor against predators. Its underside had a flat, muscular foot like that of a snail, which it likely used to glide across the seafloor. Fossil impressions suggest it fed by scraping algae or detritus with a set of specialized teeth near its mouth. Although it doesn't fit neatly into any modern animal group, it may be distantly related to mollusks. Wiwaxia represents one of the many experimental body plans that flourished in early marine ecosystems. One extinct whale had teeth like a modern killer whale's, but bigger. Leviathan melvillei was a massive predatory whale that lived about 12 million years ago. It was similar in size to a modern sperm whale, but had one striking difference: enormous, functional teeth in both its upper and lower jaws. Each tooth could reach over a foot in length, making them the largest known biting teeth of any animal, living or extinct. Fossil evidence suggests Leviathan may have hunted other whales, competing with giant sharks like Megalodon for dominance in the Miocene oceans. Its powerful bite and large, echolocating head make it one of the most formidable marine mammals ever to exist. Some feathered dinosaurs had long, ribbon-like tail plumes. Epidexipteryx was a small, tree-dwelling dinosaur that lived during the late Jurassic period. It had a lightweight body, clawed hands, and a set of unusually long, decorative feathers extending from its tail. Unlike modern flight feathers, these plumes were not aerodynamic, suggesting they were used for display, possibly in mating rituals or territorial signaling. Though incapable of flight, Epidexipteryx likely climbed trees and glided short distances, using its strong limbs for balance and control. Its body was covered in simpler, fuzzier feathers, showing that feathers first evolved for insulation and display long before they were used for flight. The world's largest sea scorpion grew longer than a grown man. Echolopterus, a type of eurypterid or sea scorpion, lived around 400 million years ago and could grow up to 8 feet long. These ancient arthropods prowled the waters of what are now Europe and North America, using their clawed limbs to grasp fish and smaller invertebrates. Though they resembled modern scorpions, they were more closely related to horseshoe crabs. Some species were adapted to freshwater, while others lived in shallow coastal seas. Fossils show they had jointed limbs, complex eyes, and sharp pincers, all features that made them effective hunters. Their size and armor made them among the top predators of their time. One prehistoric mammal walked on claws instead of hooves. Homalodotherium lived in South America during the Miocene epoch and had a body shape unlike any mammal alive today. Though it was related to hoofed animals, it evolved large, curved claws on its front limbs, which it may have used to dig, grasp vegetation, or pull down tree branches. It walked with its claws turned inward, similar to how some ground sloths move today. Fossil evidence suggests it was a slow-moving browser, adapted to forested environments with dense underbrush. Its unique anatomy shows how evolutionary pressures in isolated ecosystems like ancient South America could produce entirely new body types that defy modern comparisons. Early whales once walked on land before returning to the sea. Ambulocetus, whose name means walking whale, lived around 48 million years ago and represents a crucial stage in whale evolution. It had the body of a crocodile and the skull of a mammal, with strong limbs capable of supporting its weight on land. Fossils show that it hunted in shallow rivers and coastal waters, moving between land and water much like modern otters or seals. Over time, its descendants became more fully aquatic, eventually losing their back legs entirely. Ambulocetus shows how major evolutionary transitions, like the move from land back to sea, can be traced one fossil at a time. One tiny mammal actually fed on baby dinosaurs. Repenomamus was a small but fierce mammal that lived during the early Cretaceous period. Most mammals at that time were tiny insectivores, but Repenomamus broke the mold. It was about the size of a modern badger and had strong jaws and sharp teeth suited for meat eating. Fossils from China have been found with dinosaur bones preserved in their stomach contents, including juvenile Psittacosaurus. This discovery overturned long-held assumptions that early mammals were passive, harmless creatures hiding from dinosaurs. Instead, it revealed a more complex and competitive prehistoric world, where mammals and dinosaurs interacted as both predators and prey. South America once hosted herbivores with hippo-like skulls. Toxodon was a large, thick-bodied mammal that lived during the Ice Age and puzzled early paleontologists, including Charles Darwin, who collected its remains during his voyage on the HMS Beagle. It had a heavy barrel-shaped body, strong limbs, and a massive head with unusual tusk-like teeth. Its skull featured deeply set eyes and nostrils positioned high on the snout, which led scientists to believe it may have spent time in water, similar to modern hippos. Despite its size, Toxodon was a plant eater, grazing on tough grasses and shrubs. It was one of the last members of a unique South American lineage of mammals that vanished after humans arrived. Some snakes once reached over 40 feet in length. Titanoboa is the largest snake ever discovered, and it lived in the tropical swamps of what is now Colombia about 60 million years ago. It could grow up to 42 feet long and weigh more than a ton. This enormous constrictor likely preyed on crocodile-like reptiles and large fish, using its massive coils to suffocate its prey. The climate at the time was much warmer than today, allowing cold-blooded animals like snakes to reach incredible sizes. Fossilized vertebrae of Titanoboa suggest it was not only long but also powerfully built, a true apex predator in a lush, post-dinosaur rainforest ecosystem. The earliest primates were no bigger than squirrels. Purgatorius lived shortly after the extinction of the Nanavian dinosaurs, around 65 million years ago. It was a small, tree-dwelling mammal with flexible ankles, grasping toes, and teeth adapted for an omnivorous diet. Though it lacked the large brain or social complexity of modern primates, it represents one of the earliest members of the group that would eventually lead to monkeys, apes, and humans. Fossils have been found in North America, and their structure suggests that Purgatorius was already adapted to life in the trees, foraging among leaves and branches. In this tiny, nimble creature, we see the faint beginnings of our own evolutionary path. Some prehistoric mammals had forked horns on their heads. Brontotherium was a massive herbivore related to modern rhinoceroses, though it lacked a true horn. Instead, it had a bony, Y-shaped structure on its nose, formed by the fusion of nasal bones. This forked appendage may have been used in displays or clashes between males during mating season. Brontotherium lived in North America during the Eocene epoch and traveled in herds across ancient floodplains. Standing over 8 feet tall at the shoulder and weighing several tons, it was among the largest mammals of its time. Its fossils are often found in large bone beds, suggesting it may have lived in social groups, much like elephants do today. Giant armadillo relatives used their tails like medieval flails. Bonocthus was a type of glyptodont, an extinct armored mammal that lived in South America during the Pleistocene. It resembled a massive armadillo with a dome shell made of interlocking bony plates and a short, powerful tail encased in rings of armor. The tail ended in a thickened knob that could have been used as a weapon against predators or rivals. Fossils show it lived in dry grasslands and open savannas, feeding on tough, fibrous plants. Like other glyptodonts, Bonocthus may have been hunted by early humans. Its unique tail structure stands out as one of the most dramatic defensive adaptations in prehistoric mammals. New Zealand once had eagles that hunted giant birds. Harpagornis moray, better known as the Host's eagle, was the largest eagle species ever recorded. With a wingspan of up to 10 feet and powerful talons the size of a tiger's claws, it preyed on the massive flightless moa, birds that could weigh over 500 pounds. The eagle's attack style involved diving from above and striking the moa's back or neck with lethal force. It evolved in isolation on New Zealand, where there were no native land mammals and birds filled most ecological roles. When humans arrived and hunted the moa to extinction, the Host's eagle quickly followed, disappearing just a few hundred years ago. Some ancient reptiles had sails rising from their spines. Edaphosaurus was an early herbivorous reptile that lived over 300 million years ago, long before the dinosaurs. Its most striking feature was the tall sail along its back, formed by elongated vertebrae and likely covered in skin. While its close relative Dimetrodon was a predator, Edaphosaurus was a peaceful plant eater, feeding on ferns and primitive vegetation. The function of the sail is still debated. It may have been used to regulate body temperature, store fat, or serve as a display for mating or intimidation. Despite its lizard-like appearance, Edaphosaurus belonged to the synapsids, the same ancient lineage that would eventually give rise to mammals. The line between amphibian and reptile wasn't always clear. Samaria was a transitional species that lived around 280 million years ago during the Permian period. It had many features typical of reptiles, including a strong skeleton and robust limbs that allowed it to move efficiently on land. However, fossil evidence suggests that its young may have had gills and lived in water before metamorphosing, a trait more typical of amphibians. Because of this dual lifestyle, Samaria is considered a key evolutionary bridge between amphibians and early reptiles. It lived in swampy lowlands and lightly hunted insects and other small invertebrates. Its fossils have been found in both North America and Europe. A prehistoric armored mammal may have lived inside its own shell. Doedicurus was a heavily armored glyptodont that lived in South America during the last ice age. its body was protected by a massive dome-shaped shell composed of thousands of interlocking bone plates. It also had a club-like tail encased in armor, possibly with sharp spikes at the tip, which it could swing like a mace to defend itself from predators. Weighing over a ton and measuring 12 feet in length, Doedicurus was among the largest of its kind. There is speculation that early humans used the empty shells of gyptodonts like Doedicurus as shelters after the animals died, taking advantage of their natural protection. The largest rabbit in history lived on an island in Spain. Neuralagus rex, also known as the Minorcan giant rabbit, lived around 3 to 5 million years ago on the Mediterranean island of Minorca. It was about 6 times heavier than a modern rabbit and likely weighed over 20 pounds. Unlike its modern relatives, Neuralagus had short limbs, a stiff spine, and a heavy skull, making it incapable of hopping. Without predators on the island, it evolved a slow ground-based lifestyle and lost many of the traits that make rabbits agile. This process, known as island gigantism, occurs when animals in isolated environments grow larger due to the absence of threats. Its extinction likely followed the arrival of humans or environmental changes. One extinct primate may have reached over 10 feet tall. Gigantopithecus was the largest primate to ever live, standing an estimated 10 feet tall and weighing up to 1,000 pounds. It lived in Southeast Asia during the Pleistocene and is believed to have been a close relative of modern orangutans. Fossil teeth and jawbones suggest it was a plant-eater, feeding on bamboo, fruits, and other vegetation. Its size likely helped deter predators, but may have also made it vulnerable to environmental change. As forests receded and food became scarcer, Gigantopithecus populations declined. Some cryptozoologists have linked it to legends of the Yeti or Bigfoot, but no evidence supports its survival beyond the fossil record. The first marsupials looked nothing like kangaroos or opossums. Synodalphis is one of the earliest known marsupials, discovered in China and dating back about 125 million years. It was a small, shrew-like animal that likely lived in trees, feeding on insects and other small prey. Its fossilized skeleton shows grasping hands and feet, along with a long, flexible tail, all adaptations for climbing. What makes Synodalphis important is its place in the evolutionary timeline. It helps mark the split between marsupials and placental mammals, offering clues about how these two major groups of mammals began to diverge. The preservation of its fossil was so detailed that soft tissues and fur outlines were still visible. Some reptiles had skin as tough as tank armor. Scutosaurus was a heavily built reptile that lived during the late Permian period, about 260 million years ago. Its name means shield lizard, and for good reason. Its body was covered in thick, bony plates, offering protection against the many large predators of the time. Despite its intimidating appearance, Scutosaurus was a slow-moving herbivore that grazed on low-lying plants and roots. It had strong, column-like legs and a broad, muscular body to support its heavy armor. Fossil remains have been found in regions of modern-day Russia. It went extinct during the massive Permian-Triassic extinction event, which wiped out over 90% of marine and terrestrial species. Madagascar was once home to birds taller than ostriches. Epeornis, also known as the elephant bird, was one of the largest birds to ever live. Native to Madagascar, it could grow over 10 feet tall and weigh more than 800 pounds. It was flightless, with thick legs and a massive body adapted for a ground-dwelling lifestyle. Its eggs were enormous, larger than any other known bird egg, and could hold over 2 gallons of liquid. Despite its size, the elephant bird likely fed on fruits and vegetation. It went extinct just a few hundred years ago, probably due to a combination of human hunting, habitat destruction, and the collection of its eggs. Its story highlights how even the largest animals can be vulnerable to subtle environmental pressures. The ocean once held mammals that looked like aquatic hippos. Paleoparadoxia was a large, herbivorous marine mammal that lived along the coasts of the North Pacific during the Miocene epoch. It belonged to an extinct group called desmostilians and had a bulky, barrel-shaped body with strong limbs for walking underwater. Its teeth were uniquely shaped for grinding tough aquatic plants like kelp and seagrasses. Unlike modern marine mammals, Paleoparadoxia still relied heavily on its limbs for locomotion rather than a powerful tail. Fossils have been found in Japan, California, and other parts of the Pacific Rim. Its unusual anatomy makes it a rare example of a marine mammal that didn't descend directly from whales or seals. Some mammals had jaws built to crush bone. Gobiconodon was a small but powerful mammal that lived during the early Cretaceous period, when dinosaurs still dominated the land. Unlike most mammals of its time, which were small insectivores, Gobiconodon had a strong jaw, sharp teeth, and a muscular build that suggested hunted small vertebrates and possibly scavenged. Its molars were specialized for slicing meat, and its canine teeth were well developed for gripping and puncturing. Fossils have been found in Asia and North America, revealing that mammals were already diversifying into predator roles while dinosaurs ruled above. Though it was no larger than a modern house cat, Gobiconodon was a surprisingly efficient carnivore in a dangerous world. The Irish elk had antlers spanning more than 12 feet. Megaloceros giganteus, commonly called the Irish elk, lived across Europe and Asia during the last ice age. Despite the name, it wasn't exclusive to Ireland, and it wasn't a true elk. It was more closely related to modern deer. Its most dramatic feature was its massive antlers, which could stretch wider than two grown men standing side by side. These antlers may have been used in mating displays or combat between males. While impressive, such large antlers likely required a great deal of energy to grow and may have contributed to the species' decline as climates changed and forests gave way to open plains. Its skeletons are among the most iconic Ice Age fossils. The largest land mammal ever walked without horns or tusks. Indricotherium, also known as Paraceratherium, lived around 30 million years ago and is considered the largest terrestrial mammal known to science. It stood over 16 feet tall at the shoulder and may have weighed more than 20 tons, heavier than a modern elephant. Despite its immense size, it had no horns or tusks, and its skull was relatively smooth and elongated. It likely used its long neck to browse from tall trees, similar to how giraffes feed today. Fossils have been found across Asia, from Pakistan to China. Its sheer scale is a reminder of how much biological variety the mammal lineage once contained. South America once had predators that looked like hyenas, but weren't. Borhina was a meat-eating mammal that lived in South America during the Miocene epoch. Though it resembled a hyena in both skull shape and posture, it wasn't related to modern carnivores at all. Instead, it was part of a new extinct group of mammals called Sparassodonts, relatives of marsupials. With strong jaws, sharp teeth, and a powerful build, Borhina was likely both a hunter and a scavenger. It evolved in isolation on a continent where placental predators like cats and dogs didn't yet exist. Once the continents reconnected and true carnivores moved south from North America, Borhina and its relatives were gradually outcompeted and eventually disappeared. Some dinosaurs glided using feathers on all four limbs. Microraptor was a small, feathered dinosaur from the early Cretaceous period, roughly 120 million years ago. What makes it especially remarkable is that it had long flight feathers not just on its arms, but also on its legs and tail, giving it four wing-like surfaces. This unusual arrangement allowed it to glide between trees, possibly hunting insects, small reptiles, or mammals. Fossil impressions show fine details of its plumage, including iridescent coloring similar to modern crows. Microraptor helps bridge the gap between dinosaurs and birds, offering insight into how flight may have evolved gradually from gliding ancestors. The seas once held fish that could swallow prey whole. Xiphactinus was a large predatory fish that lived during the late Cretaceous period. It could grow over 20 feet long and had a mouth full of sharp, needle-like teeth. Its body was streamlined for speed, and fossil evidence suggests it was capable of sudden, rapid strikes. One of the most famous Xiphactinus fossils ever found includes an entire undigested fish inside its stomach, showing that it regularly swallowed prey whole, even when it was dangerously close to its own size. These aggressive predators swam in warm, inland seas that once covered much of North America. Despite their fish-like appearance, their behavior more closely resembled that of marine reptiles or sharks. One amphibian had a skull shaped like a boomerang. Diplocaulus lived during the Permian period and is best known for its distinctive head shape, two long, curved extensions that swept backward from its skull, forming a wide crescent. This odd design may have helped it steer in water or deter predators by making it harder to swallow. It lived in freshwater environments and probably fed on small fish and invertebrates. Despite its alien appearance, Diplocaulus was an early amphibian, part of a group that thrived before the rise of reptiles. Its fossils have been found across North America and North Africa, always with that unmistakable boomerang-shaped skull fully intact. Before cats ruled, other predators had even stronger jaws. Hyaenodon was one of the top predators of the Eocene and Oligocene epochs, living across North America, Europe, and Asia. It belonged to a now extinct group of carnivorous mammals called creodontes, which were dominant before the rise of true carnivores like cats and dogs. Hyaenodon could grow as large as a modern lion and had a massive skull with an elongated snout filled with sharp, shearing teeth. Its bite force was extreme, allowing it to crack bone and consume entire carcasses. Fossil sites suggest it may have hunted alone or in small groups, preying on ancient horses, camels, and other early mammals. Some dinosaurs had heads like parrots and frills like dragons. Protoceratops was a small plant-eating dinosaur that lived in Mongolia during the late Cretaceous. It had a beaked snout similar to a parrot and a distinctive frill extending from the back of its head. Though it lacked the large horns of its more famous relatives like Triceratops, its frill may have served as a display structure or a way to anchor jaw muscles. Fossils of Protoceratops are especially abundant, and some show dramatic scenes, including one famous specimen found locked in combat with a predatory velociraptor. These detailed fossils provide rich insight into the behaviors and habitats of small ceratopsian dinosaurs. Ancient amphibians sometimes grew longer than crocodiles. Metaposaurus was a massive flat-headed amphibian that lived during the late Triassic period, more than 200 million years ago. It could grow over 6 feet in length and had a broad triangular skull filled with sharp teeth, perfect for ambushing prey in murky water. Its limbs were short and paddle-like, suggesting it spent most of its life swimming in lakes and rivers. Like modern amphibians, it likely laid eggs in water and passed through a larval stage. Fossil beds containing dozens of individuals suggest they may have gathered seasonally in shrinking pools during droughts. Though it resembled a crocodile in shape, it belonged to an entirely different and long-extinct branch of the amphibian family tree. One giant cephalopod had a cone-shaped shell the size of a canoe. Camarasaurus was a marine predator that lived during the Ordovician period, over 400 million years ago. It belonged to a group called orthoconic nautiloids, ancient relatives of squids and octopuses, and had a straight, tapered shell that could grow over 20 feet long. With tentacles extending from its head and a beak-like mouth, it would have hunted trilobites, small fish, and other invertebrates in shallow seas. It moved by jet propulsion, drawing water into its body and forcing it out in pulses. As one of the largest animals of its time, Camarasaurus was an early experiment in building size and complexity in the animal kingdom. Some extinct mammals had skulls covered in horn-like bumps. Uintatherium was a large herbivorous mammal that lived during the Eocene epoch in what is now North America and Asia. It resembled a bulky rhinoceros, but was unrelated to modern rhinos. Instead, it had a heavy, elongated skull, adorned with 6 knobby protrusions that may have supported small, skin-covered horns. Its upper jaw also held a pair of prominent, downward-pointing tusks, possibly used for defense or digging. With its massive body and strange headgear, Uintatherium would have stood out even among other prehistoric megafauna. It lived in swampy forests and fed on soft vegetation, disappearing as climates shifted and new herbivores evolved. Cretaceous seabirds once flew with mouths full of sharp teeth. Ichthyonis was a bird that lived around 90 million years ago and looked remarkably modern, with wings, a beak, and a strong, streamlined body for flight. But unlike today's birds, it still had rows of small, pointed teeth lining its jaws. Its name means fish bird, and it likely hunted in marine environments, diving or skimming across the water's surface to catch prey. The discovery of Ichthyonis helped paleontologists understand that modern birds evolved gradually from toothed ancestors. Its fossils are among the earliest to show a beak structure forming alongside retained teeth, a snapshot of evolution in transition. One extinct mammal hopped like a kangaroo but looked like a rodent. Leptictidium was a small, agile mammal that lived during the Paleocene and Eocene epochs, shortly after the extinction of the dinosaurs. It had long hind limbs and a long, stiff tail, which it used to balance while leaping through underbrush. Its forelimbs were shorter and likely used for grasping or digging. Fossil evidence suggests it fed on insects, small vertebrates, and possibly fruit. With its long snout and alert eyes, Leptictidium looked like a cross between a shrew and a jerboa. It thrived in warm, forested environments and represents one of the many unusual forms mammals took on in the early days of their evolutionary radiation. Prehistoric crocodiles could grow as long as a school bus. Sarcosuchus, sometimes called the super croc, lived during the early Cretaceous and reached lengths of over 30 feet. It had a massive, elongated snout filled with more than 100 teeth, including thick, conical ones built for gripping slippery prey. Unlike modern crocodiles, Sarcosuchus had a bony shield on its snout and a deeper, more reinforced skull. It lived in freshwater environments and likely fed on fish, turtles, and even small dinosaurs that came too close to the water's edge. Fossils have been found in present-day Africa, revealing a creature that was not just large, but remarkably well adapted to its ecological role as an ambush predator. The earliest whales looked more like dogs than dolphins. Pachycetus lived around 50 million years ago and was one of the earliest known ancestors of modern whales. It had 4 sturdy legs, sharp teeth, and a long, narrow skull, with eyes positioned high on its head, ideal for peering just above the surface of the water. Though it could walk on land, fossil evidence suggests it spent much of its time in shallow rivers and coastal environments, hunting fish and aquatic prey. Its inner ear bones show early adaptations for underwater hearing, marking a key step in the transition from land mammals to fully marine animals. Over millions of years, Pachycetus's descendants would evolve into sleek, finned whales. Some herbivores were pig-shaped, but genetically unique. Mericoidodon, also known as the oreodont, was a hoofed mammal that lived in North America during the Eocene and Oligocene epochs. It had a stocky body, short limbs, and a face that resembled a pig or sheep. but it belonged to a distinct and now extinct branch of the mammal family tree. Oreodonts had complex teeth for grinding plants and were likely well adapted to grazing in open woodlands. Their fossils are among the most common in the American West, often found in great numbers, suggesting they lived in large herds. Despite their pig-like appearance, they were more closely related to camels and deer than to modern pigs. Sea reptiles once evolved shells shaped more like armor plates. Enodus was a placidont, a group of marine reptiles that lived during the Triassic period. Unlike turtles, which evolved their shells from ribs and backbones, Enodus had a flat, square shell formed from bony plates embedded in its skin. Its body was wide and low, almost resembling a living raft. It had a short, beak-like snout and likely fed on aquatic vegetation, scraping algae from rocks or consuming soft plants from shallow waters. Fossils suggest it may have had skin flaps over its eyes and a bottom-dwelling lifestyle. Enodus shows that shell-like protection evolved more than once in very different ways across Earth's history. Some mammal-like reptiles had heads that looked like dogs. Synagnathes lived during the Triassic period and belonged to a group of synapsids, ancient creatures that bridged the gap between reptiles and mammals. It had a long snout, sharp teeth, and a jaw joint more similar to mammals than to other reptiles. Its body was low to the ground, with a sprawling gait and likely patches of fur. Though it looked like a reptile in many ways, it had features such as a secondary palate and differentiated teeth, key mammalian traits. Fossils have been found in Africa and South America, showing that early mammal ancestors had already begun spreading across ancient supercontinents. Giant hornless rhinos once towered above modern giraffes. Paraceratherium, sometimes called the indricother, lived about 30 million years ago and is considered the largest land mammal ever discovered. It could stand 16 feet tall at the shoulder and reach over 26 feet in length. Despite its immense size, it had no horns and a relatively small skull compared to its body. Its long neck allowed it to browse leaves from tall trees, filling a role in its ecosystem similar to modern giraffes. Its fossils have been found across Central and East Asia, from Mongolia to Pakistan. The sheer scale of Paraceratherium challenges our understanding of how big mammals can get without collapsing under their own weight. The earliest horses were small, forest-dwelling mammals. Propaliotherium lived during the Eocene epoch and stood only about a foot tall at the shoulder, more like a terrier than a modern horse. It had 4 toes on its front feet and 3 on the back, suited for walking on soft forest floors. Its teeth suggest it fed on soft leaves and fruit, browsing in dense woodlands. Unlike the grazers of today, early horses were adapted for a very different world, one of lush, tropical forests rather than open plains. Fossils of Propaliotherium have been found in Europe, offering a glimpse into the early stages of horse evolution before grasslands and hooves shaped their future. One armored dinosaur left behind skin as well as bones. Borealepelta was a heavily armored dinosaur that lived during the early Cretaceous period in what is now Canada. It belonged to the Nodosaur family and was covered in bony plates and spikes from head to tail. Remarkably, its fossil was found so well preserved that not only were its bones intact, but impressions of its skin and even traces of its original coloration were still visible. Analysis suggests it had reddish-brown tones with darker patterns along its back, a form of camouflage called countershading. This discovery has provided some of the best insight into dinosaur skin texture, armor layout, and even pigmentation ever uncovered. Some ancient mammals have skulls shaped like melted antlers. Eobasileus, a member of the extinct Dinoceraton group, lived in North America during the Eocene epoch and was one of the largest land mammals of its time. It had a bulky body, massive jaws with sharp tusks, and a skull adorned with 6 horn-like protrusions, bony knobs that jutted upward and to the sides like irregular antlers. These structures may have been used in mating rituals or dominance contests, similar to how modern animals use antlers and horns today. Though it looked fierce, Ear basilius was an herbivore, feeding on soft plants in forested environments. Its unusual appearance reflects the wide range of evolutionary experiments that occurred in the aftermath of the dinosaur extinction. The first amphibians grew into forms stranger than most reptiles. Temnospondyls were a diverse group of early amphibians that lived from the Carboniferous to the Triassic period. Some were small and lizard-like, while others reached lengths of 20 feet or more, with massive flat skulls and broad, sprawling limbs. They inhabited swamps, lakes, and river systems, where they hunted fish and invertebrates using ambush tactics. Their fossil record spans multiple continents, showing how widespread and varied these creatures became. Some species may have given rise to modern amphibians, though many were evolutionary dead ends. Their mix of aquatic and terrestrial adaptations shows just how flexible life could be during Earth's early experiments with vertebrate anatomy. A once common migratory locust now exists only in records. Gastrymargus musicus, the Australian plague locust, was a highly mobile insect that once swarmed across vast stretches of grassland in massive clouds. Though related swarming species still exist, several regional forms are believed to be extinct due to habitat loss and changes in land use. Migratory locusts like this one had enormous ecological impacts, consuming vegetation at a rate that could devastate entire ecosystems or crops. Locust extinctions are rarely noticed because of their transient, unpredictable nature, but they highlight how even resilient and widespread species can vanish under sustained environmental pressure. Their disappearance may be a warning sign for how shifting climates affect even the most adaptable insects. Sea scorpions once terrorized ancient coastlines. Carcinosoma was a type of eurypterid, an extinct group of aquatic arthropods that lived in shallow marine and coastal waters over 400 million years ago. Some individuals reached lengths of 6 feet, with segmented bodies, large pincers, and paddle-like limbs for swimming. They were among the top predators of their time, hunting trilobites, fish, and other invertebrates. Fossils show that Carcinosoma had well-developed compound eyes, allowing it to see clearly in low light. Although they resembled modern scorpions, they were more closely related to horseshoe crabs. Their extinction marked the end of an era in which arthropods dominated the seas. One dinosaur had claws longer than a human arm. Therizinosaurus was a bizarre feathered dinosaur that lived in Mongolia during the late Cretaceous period. Its most distinctive feature was its enormous claws, each one measuring over 3 feet long. Though they looked terrifying, these claws were not used for hunting. Therizinosaurus was an herbivore and may have used them to pull down branches or defend itself from predators. Its body was large and bulky, with a long neck and small head, and its skeleton shows evidence of feathers. For years, only its claws were known, leading to wild speculation about its identity. Today, it's recognized as one of the strangest members of the theropod group, a dinosaur built like a predator, but evolved to eat plants. Prehistoric platypuses had a full set of sharp teeth. Obdurodon was an ancient relative of the modern platypus that lived in Australia several million years ago. Unlike the platypuses alive today, which lose their teeth as adults, Obdurodon retained its molars and incisors throughout life. These teeth were well suited for crushing small invertebrates, shellfish, and aquatic prey. It still had the familiar duck-like bill and webbed feet, but its diet and anatomy suggest it hunted more actively in streams and rivers. Fossils of Obdurodon have been found in what were once subtropical rainforests, revealing that monotremes, the egg-laying mammals, were once more diverse and specialized than they are today. the largest sea turtle ever lived over 70 million years ago. Archelan was a marine turtle that could grow more than 13 feet long and weigh up to 5,000 pounds, much larger than any sea turtle alive today. It had a broad, leathery shell and elongated flippers, ideal for long-distance swimming across ancient oceans. Fossils suggest it fed on soft-bodied prey like squid and jellyfish. Unlike modern turtles with hard, domed shells, Archelan had a more flexible, cartilaginous structure, making it lightweight for its size. It lived in the warm, shallow seas that once covered North America during the late Cretaceous period, sharing its habitat with mosasaurs, ammonites, and other marine reptiles. One small dinosaur had a beak like a modern parrot. Psittacosaurus lived during the early Cretaceous period and is one of the most well-known early ceratopsians, the group that includes Triceratops. It was about the size of a large dog and had a short, robust beak shaped very much like a parrot's, ideal for cropping tough vegetation. Fossils show it may have had bristle-like structures on its tail and cheeks, possibly for display. Juvenile specimens have been found in what appear to be nesting groups, hinting at complex social behavior. Its wide distribution and exceptional fossil record have made Psittacosaurus a key species for understanding the early evolution of horned dinosaurs. A fossilized whale was found with a fetus still inside. Myocetus, meaning mother whale, lived around 47 million years ago and represents a critical stage in whale evolution. It still had fully functional limbs for walking on land, but its body was already adapted for swimming. One fossilized female was discovered with a near-term fetus preserved inside, positioned head first, the typical birth posture for land mammals. This strongly suggests that Myocetus gave birth on land rather than in water, offering rare insight into reproductive behavior during a major evolutionary transition. The discovery provides compelling evidence of how whales gradually adapted from land-based ancestors to fully aquatic lives. Some Ice Age cattle were larger than modern bison. Pilorovis, also known as the African giant buffalo, lived during the Pleistocene and had massive, curving horns that could span over 10 feet from tip to tip. It was a close relative of modern bovines and may have resembled a cross between a bison and a wild ox. Fossils show it stood merely 6 feet at the shoulder and weighed over 2,000 pounds. It lived in open grasslands and likely grazed in large herds. Its sheer size and powerful build would have made it a formidable presence in the prehistoric African savanna. Climate changes and human hunting likely played a role in its extinction. South America once had elephants with corkscrew-shaped tusks. Notiomastodon was a member of the Gonfathers, a group of extinct elephant-like mammals that once ranged across the Americas. Unlike modern elephants, Gonfathers often had unusual tusk shapes, including downward curves, twists, and spirals. Notiomastodon lived in South America during the late Pleistocene and had large, gently curved tusks and a shorter, more compact body than today's elephants. Fossils have been found in association with early human artifacts, suggesting they were hunted for meat and ivory. These animals were among the last of their kind, disappearing around the same time as mammoths and other Ice Age giants at the close of the last glacial period. One carnivorous opossum was the size of a modern bobcat. Thylophorops was a large, extinct marsupial that lived in South America during the Pleistocene epoch. Unlike modern opossums, which are mostly omnivorous scavengers, Thylophorops had strong jaws, sharp teeth, and a more robust body, suggesting it was a dedicated predator. It likely preyed on rodents, reptiles, and small ground-dwelling animals, filling a niche similar to that of small wild cats or foxes. Fossils show that it had a more upright gait than its modern relatives, and its limb proportions hint at bursts of speed or powerful ambushes. This predator demonstrates the ecological variety that marsupials once held before placental mammals became dominant in South America. Some feathered dinosaurs had tail fans for display. Caudipteryx was a small, fast-running dinosaur that lived in what is now China during the early Cretaceous. Its body was covered in feathers, and its tail ended in a fan-like arrangement of stiff plumes. Although it had short arms with symmetrical feathers, it was flightless, suggesting its feathers evolved for other purposes, such as thermoregulation or display. Its beaked mouth, large eyes, and light frame point to an active lifestyle, possibly including insect hunting or seed eating. Caudipteryx is considered one of the clearest transitional fossils between Nanavian dinosaurs and birds, revealing how feathers evolved long before powered flight. Saber-toothed predators existed long before true mammals. Sauropterus was a member of the Gorgonopsids, a group of synapsids that lived during the late Permian period. These ancient predators had long, saber-like canines, forward-facing eyes, and powerful jaws. Despite their reptile-like appearance, Gorgonopsids are more closely related to mammals than to lizards or crocodiles. Sauropterus likely hunted large herbivores like Scutosaurus, delivering deep, puncturing bites with its blade-like teeth. It walked with a semi-upright gait and had a flexible spine, suggesting speed and agility. Gorgonopsids were among the dominant predators of their time, but they vanished during the Permian-Triassic extinction, clearing the stage for the rise of true mammals. Some ancient deer grew enormous, spiral-shaped horns. Synthetoceras lived in North America during the Miocene epoch and stood out for the unique structure on its head: two forward-curving horns above the eyes, and a third, long, forked horn growing from its nose. These strange appendages were likely used in male-to-male combat or species recognition. Its body resembled that of a small antelope, and it fed on shrubs and soft vegetation in open habitats. Fossils show that it belonged to a group of extinct hoofed mammals known as protoceratids, which had no direct modern descendants. The elaborate horn structure of Synthetoceras is a striking example of how evolutionary pressures can lead to highly specialized anatomy. One dinosaur had a single claw used for digging or slashing. Mononychus was a small bird-like dinosaur that lived in Mongolia during the late Cretaceous period. It had short, stout arms ending in a single large claw on each hand, a highly unusual feature among theropods. Scientists believe this claw may have been used for digging into termite mounds or burrowing into soft ground. Mononychus had a sleek body, long legs, and a beaked snout, suggesting it was a fast runner and possibly an insectivore. Its skeleton shares many features with early birds, and it was likely covered in feathers. Despite its small size, Mononychus reveals a great deal about the diversity and specialization of Nanavian dinosaurs. The earliest turtles still had visible teeth. Odontochlis is one of the most primitive turtles ever discovered, dating back to the late Triassic period over 200 million years ago. Unlike modern turtles, which have beaks, Odontochlis still retained small, pointed teeth in its jaws, a feature lost in its descendants. Its shell was also incomplete. It had a fully formed plastron, the bottom shell but only partial protection on its back, suggesting the turtle shell evolved in stages. It lived in shallow marine environments and lightly fed on soft-bodied prey. Odontochlis provides crucial insight into how the turtle's unique body plan developed over time through evolutionary change. Some ancient giraffes had bodies like moose and horns like antlers. Silitherium was a large, extinct giraffid that lived during the Pleistocene in parts of Africa and southern Asia. Unlike modern giraffes, it had a short, powerful neck and a bulky frame, more like a moose or elk. Its skull carried a pair of thick ossicones, horn-like structures, along with a second pair of bony projections above the eyes, giving it a striking prehistoric look. Males may have used these structures in dominance contests or mating displays. Though less specialized for high browsing than today's giraffes, Civatherium was still a tall browser and part of the diverse evolutionary tree that gave rise to modern giraffids. One ancient rhino had no horns and looked more like a tapir. A Civatherium was a hornless rhinoceros that lived in Europe and Asia during the Miocene epoch. Its name literally means hornless beast, and it had a long, low skull with large teeth for grinding tough plant matter. Unlike modern rhinos, it had a more slender build and may have possessed a small trunk or flexible upper lip, similar to that of a tapir, to help it grasp leaves and shoots. Fossils suggest it lived in open woodlands and grasslands, feeding on coarse vegetation. Civatherium belonged to a widespread group of early rhinoceroses that flourished before more modern, horned forms evolved. Some ancient reptiles had sails running the length of their backs. Hypsilorhachis was a mysterious prehistoric reptile known primarily from its unusually tall vertebrae, which formed a long, spiny sail along its back. The function of the sail is uncertain. It may have been used for temperature regulation, species recognition, or display during mating. Hypsilorhachis lived during the Middle Jurassic, and while little is known about its overall body plan, its spine suggests it was part of a broader evolutionary experiment in dramatic body structures. Similar back sails evolved independently in other lineages, including pelycosaurs and some dinosaurs, highlighting a recurring theme in vertebrate evolution. A saber-toothed predator once roamed North America's ancient plains. Barbara fleas was a powerful carnivore that lived during the Miocene epoch and resembled the more famous Smilodon, but it came from a different lineage entirely. Often called a false saber-tooth, it had massive upper canines, a short, deep skull, and muscular limbs built for grappling with prey. Unlike modern cats, it had a wider gape and shorter face, allowing it to drive its saber teeth into soft tissue with precision. Fossils suggest it hunted large herbivores and may have competed with early true cats and dog-like predators. Though extinct, Barbara fleas shows that saber teeth evolved multiple times in separate carnivorous groups. A marine lizard once rivaled sharks as the top predator of the sea. Mosasaurus was a giant marine reptile that lived during the late Cretaceous and could grow over 50 feet long. With a long, muscular body, paddle-like limbs, and a powerful tail, it was a fast swimmer capable of ambushing prey with incredible force. Its jaws were lined with dozens of conical teeth, ideal for gripping fish, ammonites, and even other marine reptiles. Unlike crocodiles, Mosasaurus had double-hinged jaws and flexible skull bones, allowing it to swallow large prey whole. It ruled the oceans during the final age of dinosaurs, and its discovery helped reshape our understanding of ancient marine ecosystems. An extinct giraffe relative had a neck too short for trees, but just right for strength. Samotherium lived in Eurasia during the Miocene and was a close cousin of modern giraffes. It had a much shorter neck than today's species, but still longer than most hoofed mammals. This intermediate length may have been used in neck-based combat, a behavior known in modern giraffes as necking, where males swing their heads and necks to strike rivals. Fossil evidence from Samotherium helps paleontologists understand how giraffe necks evolved, not just for feeding at height, but also for social competition. Its limb bones and skull anatomy show a blend of ancient and modern traits, offering a glimpse into a pivotal moment in giraffe evolution. And so, from the buzzing jungles of the Carboniferous to the icy plains of the Pleistocene, the story of life has been written again and again in forms now long gone. Though these creatures no longer walk the earth, their bones still speak. In every fossilized tooth, every weathered skull, every trace in ancient stone, we find echoes of a planet forever changing, and lives that once filled it with sound and motion and mystery. Extinction is not an end, but part of the story, a pause before something new. And so, under the quiet stars, the story continues. I hope you sleep well and dream softly. Good night.